In section 2.6, we're going to talk about perimeters and areas of similar figures. So we're going to actually figure out, if we have similar figures, how it relates to the perimeter and the area of those figures. So we have two key ideas today. Here's your first one. Here's your key idea. Perimeters of similar figures. So this is talking about perimeters. When two figures are similar, the ratio of their perimeter is equal to the ratio of their corresponding side lengths. As we already know, the side lengths are always proportional. Using that, we know that their perimeters are also equal to the ratio of the corresponding sides. So here is how it's going to look. So if we look at this, we already know that if these two shapes right here, these two triangles are similar, that AB and DE can be written as a ratio that is equal to the ratio of BC and EF, which is equal to AC divided by DF, because these are all can be written as a proportion, because they're all the equal ratios. The perimeter is also the same fraction or the same ratio as the fraction you're going to get for all of the sides. For example, if this was 4 and this was 8, you'd have a ratio of 4/8, which is 1/2. The perimeter would also be in that same ratio as 1/2. So let's do an example using this key idea. Here is example 1. I want you to draw two different sized rectangles. Now we're going to know that these rectangles are similar. I want you to find the ratio, red to blue, of the perimeters of these similar triangles. So the first thing you do is just take two sides, any two sides, and write them as a ratio. So I could say that the perimeter is going to be in a ratio of 4:6 because we know that these two sides can be written as a ratio, 4:6. 4:6 can be written as a fraction 4/6. 4/6 can be simplified into 2/3. So we know as well that the perimeter has to be in a ratio of 2/3. So now I'm going to go one step further. Let's say that we know this. The second part will say the perimeter of the red rectangle is 20. What's the perimeter of the blue rectangle? So all we do now is take this one step further. We know that the perimeter of the red, which is 2, remember the red is this, the blue is the bottom, so 2/3, equals. If the perimeter of the red rectangle is 20, what is the blue? We can write a proportion because we know it's in the ratio of 2/3. Cross multiply. 2 times x is 2x, 3 times 20 is 60. Divide by 2, the perimeter of the blue rectangle would be 30 centimeters. And that would be my answer. Our next key idea has to deal with the areas. The areas of similar figures. When two figures are similar, the ratio of their areas is equal to the square of the ratio of their corresponding side lengths. So we're going to use the two triangles in the other diagram that we drew. We know this. We know that if we took the area of the first triangle, the red triangle, which is ABC, and the area of triangle DEF, the blue one, that's going to be equal to the ratio of the side lengths squared. So we are going to take the ratio of one side to the next, and we're going to square it. So here is example number 2. Find the ratio, the red to blue, of the areas of the similar triangles. Now we can say that the ratio is 6:10 or 10:6, but it clearly says here that we want the red triangle to the blue. So the ratio of one side to the next is going to be 6/10. Now we want to simplify that. 6/10 equals 3/5. But in order to find the ratio of the area, you must square that. Now if you don't remember how to square something, all that means is 3/5 times itself. 3 times 3 is 9, 5 times 5 is 25. Therefore, the ratio of the areas of their similar triangles is 9/25. Here is the last problem we're going to do. Write this one down. This is example number 3. A swimming pool is similar in shape to a volleyball court. Find the perimeter and area of the pool. So it seems pretty easy. All we need to find is the perimeter of the pool and the area of the pool. So the first thing we have to do is we have to find the ratio of one side to the next. So I always like to do the smallest side versus the smallest shape versus the bigger shape. So let's write a ratio. I'm going to write a ratio of 10 to 18. So 10/18. Now 10/18 represents the width of the court, which is 10, and the width of the pool, which is 18. So I can write that as 10/18. Now if you want to simplify that, you can, but you don't have to, because that's not your answer. You have to use that 10/18 and the two key ideas to find the perimeter and area. So let's start with perimeter. If we remember our key idea, the perimeter says that the ratio of the perimeters is the same as the ratio of the side. So we can say the ratio of 10/18 is equal to the ratio of the perimeters. So here's what we know. The perimeter of the volleyball court is 60. So we have to go up here and look at, well, which one of these sides is part of the volleyball court? Well, it's 10. So I'm going to do 60 over x. So if I cross multiply, that's going to give me 10x equals 1080. I divide both sides by 10. X is going to equal 108. Now that would give me a perimeter of 108 yards for the pool. Now I have to use the exact same ratio of 10/18. But wait a minute, our key idea for area says we have to square that. So whatever ratio you get, you have to square it for the area. So I'm going to square it, and now I'm going to use 200, which is my area, over x. So if I square 10/18, 10 times 10 is 100. 18 times 18 is 324. That equals 200 divided by x. I cross multiply. 100 times x gives me 100x. 324 times 200 gives me 64,800. I divide both sides by 100. I get x equals 648. So that would give me an area of 648 yards squared. So remember, once again, your two key ideas. The key ideas state the perimeter has the same ratio as the side lengths. The area, you have to take the side length, the ratio of the side lengths, and square it. And that's it. That's how you find the area and perimeter involved with similar figures.